Hi, everyone. Hello, thank you very much for joining us and welcome to this webinar about parametric analysis. We're very excited at Radian. As you know, our goal is to simplify thermal analysis for space, and we think that this feature is actually going to help a lot in this process. So we're very, very happy to have you all here, and thank you for joining us. And I think we can introduce David already. David, as you know, is the CEO of Radian, and he will be driving us through a presentation on this parametric analysis, and then we'll be able to see a demo of this feature that you will have very soon available in Radian.
Yeah, hello all. Thank you very much, Laura, for your introduction. We're very excited to show you what we have developed in the past in the past month. And it's all about parametric analysis and how you can make it the most out of our tool and in an easy way create variations of and ramifications of your thermal analysis. So without further ado, let's start with a quick presentation. Most of you already know our product, but it will be very quick, just no more than 6 slides, and in which we will go through a little bit of what we've developed, and then we will jump into the demo itself, where you will see how the product performs live. So as many of you know, Radian is a thermal analysis software that is hosted in the cloud and therefore accessed via web browser. And we wanted to take advantage of this cloud nature to not only provide you with a feature that allows you to run multiple cases, but also use the cloud infrastructure itself to run these cases in parallel. So, and the default way to use Radian so far is to build a thermal model. For us, thermal models are a group of geometries and contacts and heat loads that comprise your thermal representation of your hardware. Then we have the scenarios that you can place either in orbit or in an adiabatic fashion, and to subject it to custom boundary conditions. And finally, we run a thermal solution over it, and we derive the temperatures and the heat fluxes. So this is how we conceived thermal analysis, how thermal analysis is conceived in most of the tools today. But we wanted to go one step further and then, as I said, create these assortment of features that allow you to run this with variations again and iterating your thermal analysis. So when we have the same model and multiple scenarios, we solve this in the interface. You will see it later when I share my screen and I show you how it looks in the tool. We solved creating multiple scenarios for the same model, just creating a hierarchy and a pipeline in which you can set different scenarios and therefore run different thermal solutions. However, when we have multiple models and the same scenario, it could be a different scenario, but if we have multiple configurations for the same model or multiple variations, then it starts to get tricky and you need to duplicate the whole pipeline, create a copy that gets detached from the first one. So it starts to get a little bit blurry and difficult to operate, because if you want to preserve some of these changes, then you will need to apply those changes to both models. The models are no longer coupled. So therefore, we came up with this solution of extending the simple case definition that we had, in which you have the thermal solution at the end that computes your baseline model and a scenario. And we expanded this simple case definition into a parametric case that encompasses a handful of variations that you create, and those variations affect both the model and the scenario. How do we do this? So each variation is comprised by variables, and these variables are just entities that alter their attributes, their properties, so that you can run different cases and see the impact of these changes. For us, everything is a variable. You can vary virtually anything. Our first version, the version that we are showing you today, comprises sensitivity analysis and trade-offs for the most typical applications. So if you want to vary a conductance, or you want to vary the thermooptical properties of a coating, or you want to swap your coating or material, you are able to do so already with what we've developed so far. For the future, we also want to add other properties, like the properties that affect the model, the geometrical part of the model, like dimensioning, positioning, and so forth. And we have a handful of ideas to enhance and extend this range of variable types that we have for you. So again, as I said since the beginning, this is also feasible in parallel, which means that if you have a sensitivity analysis, for instance, for a certain GL that you want to run in parallel for in different variations, then we have a cloud infrastructure that supports the execution of these intermediate tasks and final tasks that come up with the thermal solution, so that you get the same results, so all of the different cases, but all of them at the same time, all of them at once, because we have a cluster of workers that is available. So it is as if you had an assortment of computers in your own office available for you to run these different analyses. It goes a little bit beyond parallelization in the same computer in cores. We just have several machines that run the jobs for you. So this is a little bit of an introduction of what we wanted to present, but now we will move into the live demo so you can see how it actually behaves in the tool itself. Laura, I don't know if you want to jump in.
Yeah, no, for sure. I was just thinking that if anyone has any questions, we will have some time at the end to ask any questions.
Yes.
So we will give you access. If you want to raise your hand at the end of the session, you will be able to share your camera and your microphone so you can ask live, or you can also write in the chat. So yeah, if you have any questions, start thinking about them or writing them down, and we can go into them at the end of the session.
Exactly. We will be happy to address all of your questions. We have a little screenshot to help you how to raise your hand. And when you raise your hand, we will enable your user so that you can ask your question. If you want that question to be anonymized, you can either send us an email, or you can change your name and then send us or ask the question either way. So we will be happy to address all of your questions. So moving on to the live demo, we have prepared here for you a little project. And this project has two different pipelines. So this is what I was mentioning before. Our thermal analysis process is comprised of models, scenarios, and analysis cases. In this case, in the bottom part of the parametric analysis of the project, sorry, we have the default pipeline that all of the users were able to create up to today. So essentially, you will just create a model and a scenario, and finally a simple case. This is the same model for both types. We also have it here for whether there is any questions that you want to ask regarding the comparison between these two types of cases. Well, we have here the most common approach right now to run this thermal analysis. So I will just go very briefly over the model. I don't want to go over the details, but just so I show you what we are dealing with. This is just a very simple model. It's just a cube with a computer inside, which is just a box. So very simple. So it runs fast, and you see the philosophy that runs behind the parametric analysis, which is what we want to show you today. So essentially, we have just a conductor that has a value of 0.05 watts per Kelvin. That is connecting this frame to the this computer to the frame, to the outer frame of the cube. And essentially, we want to run the first thing that I want to showcase is to run a sensitivity analysis, or essentially just varying the GL value of this contact and see the impact of the variation of the value in the temperatures and the thermal results that we get in the end. If we want to do this in the usual way, we can do it in two ways. We either run the same analysis 3 times, so the one that you saw in the bottom, we run it 3 times with 3 different values for the conductance, or we duplicate it 2 times to preserve that variation, and then we vary this value, this conductance value, and we run the 3 cases at the same time. So as you could imagine, and as I was portraying in the presentation before, the UI starts to get a little bit messy in terms of you will have duplication of your model 2 times here, then you will need to write or modify the name of each model so that you can know which GLs you're varying. Is a mess. So that's why parametric analysis comes very handy in this case. So how do we do that? So we add a case just as before, and now instead of having just simple cases, which were the ones that we always had, transient or periodic for steady state solution, we also have parametric cases. So we will select parametric case, and then the parametric case also has a type of solution. So you will select what type of solution you have for this parametric case. In our case, it will be a periodic transient solution, so it cycles over and over the transient solution until it converges for one orbit. So let's just name it GL2, since we already have GL already created, and create the case. So what you see here is the canvas, the editor of your parametric case. And the first thing that you see is the baseline variation. Baseline variation means the model and scenario that you created as is. That means without any changes, without any modifications or alterations that you might add now in the different variations. This is useful if you want to run what's already in the model with something else. So you not only count with your alterations and your modifications, but also with what you already have. In this case, we will see that the value of the conductor is 0.05 watt per Kelvin, and that's the value that we are preserving for this baseline variation. Then we have a button here that is called Add Variation. If I click here, a new variation appears, and then it's empty for now, but I can add variables. And these variables were the ones that I was mentioning in the presentation. We have different types of variables that essentially group or categorize different types of entities that you can modify for the different variations. In this case, for the first variation, I will add the contact type for the variable, and then a new variable appears here. First of all, I need to select the entities. So we have all of the contacts for, in this case, since I have all of the contacts, both etched and custom made, I have all of the edge contacts here, and I also have the computer frame contact, which is the one that I'm altering in this example. And then once I select at least one entity, the attribute section appears. And in this attribute section, we allow you to select as many attributes as you were modifying in the editing phases of your baseline model or scenario. And in this case, we only have one, which is the GL. So we are going to modify that value. So I select GL, and then I set a value, for instance, of 0.001 to create an example in this case. So we have now a different value, a much lower value. But now I also want to run this sensitivity analysis with more cases. And a manual way to do so would be to create a variation again, and then add a variable, select the entity, and then modify the GL. So since that's a little bit tedious, we created a shortcut to duplicate the variation. And just essentially what it does is, you just saw it, it just creates an exact copy of your variation with all of your variables that you created, all of your entities. And now I can go here back again to the GL and just, for instance, set it at 10 watts per Kelvin. So we see a completely different result. And that's how I create variations, essentially. I just go either duplicating them or adding them, and then selecting different variables for each of those. As you can see, I can run also combined sensitivity analysis if I want to run groups of entities that might alter your results. You can combine these contacts with a thermooptical property that is changing or a material that is being swapped. We will see the other examples later, but for now, I just wanted to mention that. So once we have all of that, before jumping into the results, I just wanted to highlight that you can also disable or enable variations. If you have multiple variations and there's some results that you don't want in your final comparison for some reason, you can also disable them here and get rid of them and save time, essentially, for your final computations. So now if I click here on this results tab, I'll go to the actual control of how we run this analysis. So we see the same thing as in the simple cases. So we have the results pertaining to the model, the results pertaining to the scenario, and the results of the case. But in this case, we have several types of variations, and we will run these as well. I see that I have some already computed because I have other cases that have computed these tasks, but this is not computed yet. And the same for the two variations that I'm about to compute. So if I click here on run, this is where it all starts. So essentially, what you see here is now the percentage of the variations and all of them run in parallel and getting your results. So instead of sequentially running these cases with just one button, you just run the whole sensitivity analysis. In this case, of course, it's a very simple model because it's just 7 nodes. And as you might imagine, the speed is really high. But for other complex models, this starts to bundle up. And it's good to have something that allows you to run these tasks in parallel so that they take less time. Instead of taking, for instance, I don't know, 1 or 2 hours, it will just take you to half of it because you will run the same routine in parallel in different machines. And that's exactly what just happened here. We have a status that indicates that these variations and the baseline variation were computed correctly. And then if I hover on each of them, I see how each of the subtasks has performed. So we have computed the GLs, the GRs, the orbital heat fluxes, and finally the thermal results. For the variations 1 and 2, since they are only modifying the GLs, there's no need to compute the GRs and heat fluxes. So they just don't compute them. They just keep these GRs and heat fluxes. We want to add more information here in the future, but for now, this is as far as we can show you. Of course, once you have that, you can always go to your results and you will see your temperatures for the baseline. Let me open the variation 1 and 2 in different tabs. That's for now what you need to do. And if I show the temperature of the computer here, and if I show the temperature of the computer in the variation 1, you see that, of course, the temperature is different. So for variation 1, we have more or less within the range of 36 Celsius. And for the baseline variation, which is, again, your model and the scenario as is, you get a computer temperature of minus 14 degrees Celsius, more or less. So this was my example. Again, you can imagine that you can expand the possibilities of this and, of course, the complexity of the model. I just wanted to show you how it performs and what's the workflow like. And if I go back to the project tree, I can show you some other examples. For instance, if you have a material trade-off, that means, for instance, that you might have a material applied, in this case, for all of the geometries of your frame, and then you want to alter the material that is applied. So essentially, you can just select the material and select just a different one and run this analysis with a trade-off of materials and see which material is the one that you need for your thermal applications. The same could be said for the surfaces. You could add a surface and select different coatings for different surfaces and see how they perform. You could add a heat load and then run a thermal a sensitivity analysis with different values for that heat load. Again, the possibilities are endless. If you add, for instance, we haven't covered it here, but I can also show you, let me add it here, for instance, how to modify the properties of the material of a surface. Instead of swapping the whole material or the whole coating, as you saw, we can also modify the properties of the material itself. So we will add just a material from a geometry, let's say the FR4 of the computer. Of course, the material is separated just in case you want to cherry pick the materials from specific surfaces. They don't get changed all at the same time. And then you can select an attribute for that material and change its properties and see its effects. So yeah, that was mainly all that I wanted to show you today, but now we're open for your questions. So as you can see here, you have a button right next to the hang up button that is a hand. So if you click it, we will see that you have your hand raised, and we will address your questions here live. Thank you so much for your attention.
Right, thank you very much, David. And I think that we already have a question. And so Pablo wants to ask a question, so let us bring him in. Hi, Pablo, how are you? Can you hear us okay? Feel free to make your question. You can either unmute yourself if you want, or you can also type your question in the chat.
Exactly, as you wish, Pablo.
Can you hear me now?
Yes, we can.
Yeah. Just one question. Is it possible to plot on the same graph two variations?
That's a very good question, because that's the follow-up that we want to bring before the end of the year. We want to add these delta views. As you saw today, we have these several separate tabs for each of the variations, but you cannot contrast directly one with the other. And we want to start with these comparison views, and starting with plots, and then with 3D views as well, so that you can compare the differences between one case and one variation and the other. Yes.
Okay.
Mm-hmm.
I think for now, what we sometimes do is put them together, right? We can open
side by side,
put them
but
side
again,
by side.
if it's to be better, we know, and we want to progress on that feature and add it as soon as we can.
Okay.
Thank you, Pablo.
Great.
Okay, we have another hand that is raised.
Yep.
Okay, let's see how we can add it. You add it, Laura?
Yep.
Okay.
So, Domingo, you should be able to ask us now any question. Hello, Domingo. Can you try to unmute yourself?
Yes, sorry. Yes, I'm here. I'm Domingo from Argentina. I'm working for INVAP, so the thermal group. So my question is, because I'm not familiar with this software, right? So we use another platform, let's say. So as far as I know, you use Radian on the cloud, right?
Yes.
So my question is about running different models in parallel. So you have to run different models on the cloud, and you mentioned that different analyses are run on different nodes or computer, okay?
Yeah.
So my question is, are those computers provided by Radian, or you have to have a kind of cluster or something like that?
No, we are the ones that provide you the cloud. We have two versions of the cloud. We have a public version, and then a dedicated cloud as well that we can provide to you. But you will always outsource the computing power to the cloud that we provide to you.
Okay, so if I want, I don't know, a more powerful cluster, I have to pay more or something like that?
No, you have virtually unlimited. Every user in Radian has unlimited power and availability. We are thinking about, for now, as we progressively deploy this feature, to limit the number of variations for now, and then expand that limit as we grow, so that you can run as many variations as you want. But you could run multiple parametric cases with multiple variations all at once.
So okay. So are you using, let's say, the powerful of the CPU, not the GPU, right?
We use CPUs for now, yes.
Okay. Okay. Thank you.
Yeah.
No, but I
thank you,
think
Domingo.
that's
you for the
the
question.
beauty of Radian, right? And that's the main difference with other thermal analysis tools out there in the market, is that we make the most of the cloud, and especially with this new feature, that helps us a lot because it doesn't rely on your computer and the power of your computer. It's actually run in the server. So yeah, that's a very good question. Thank you very much, Domingo.
Okay, thank you so much.
Thank you, Domingo.
Thank you. All right. Any more questions? We had a question, David, about the variables that we can currently do in Radian. So are we planning to expand these types of variables so that we can also use it for geometrical dimensions, positions, and other variables?
Yeah, we want to, as I said in the presentation, we want to tackle these multiple configurations. That could mean anything. That could mean a deployable and a configuration, or so mechanisms in the end, or just varying the dimensions of a radiator. Anything that you might come up with in terms of dimensioning and positioning. For now, we don't have that ready yet, because that implies a change in how the viewer portrays these changes. Again, we would need to replicate how the user is changing the dimensions of or the positionings of geometries in the viewer itself. But we want to, of course, we want to tackle that, and that's why we postponed this for V2. But we want to add these variable types as well. Thank you, Laura.
Good. All right. Any other questions from anyone in the audience?
Yeah, time's running off. Otherwise, we will wrap up.
Yeah, you know that you can always ask us any questions that you have via email as well. And a few of you also mentioned that you're interested in trying Radian, so we will be in touch after the webinar today so that you can try the software for 15 days, and we will see, if there's anything you need from our side, we're always there. Actually, these type of features are always very, very good for us, and they are based on conversations that we have with all of you. So thank you very much for all of you that have tried Radian in the past, because it really informs the feature development and improves our product. So thank you very much for all of you that have tried it, and the ones that you have interest in trying. We will be in touch, and feel free to send us an email if you have any follow-up questions.
All right. Thank you all. Thank you for attending. See you around. Bye-bye.
Thank you very much.